now.
Okay.
So, because we going to start the article on hold on, I'm trying to go back to it real quickly. The resistance training improves the cellular health parameter in obese older women, a randomized control trial. Do you guys want to go first? You want me to go first?
Yeah, I can go first. Okay, so I read the article. It was a bit confusing because there wasn't much there was more like numerical data and references than it was like the actual what is this? The actual like trial information. So from what I got about it is, so basically they did a study. It started with 60 older women, and then it went down to ended up only having 33 participants for whatever reason, personal, or they didn't meet the criteria, so they were kicked out of the group. And then from there they had two groups, one group performing the resistance training and the other one doing no exercise. They all had the same medical clearance, so they did like EKG and all that stuff, and they measured the body mass. They all did the same workouts. It was, I think, 6 of them, the same 3 sets of 8 to 12. The only difference being the amount of weight that was used per person for 8 weeks. And they so they found that it's not more about like losing weight, it's about resistance training to make the let me see, so it's more in order to get more fit. It was not about like losing weight, it was about resistance training to make the big difference. But I didn't understand how that tied into the cellular level. Like I did, I read where it said like the extracellular matrix is what they're thinking increases the weight and all that stuff in people. But I think that it didn't really, I don't think it was like a fair trial because they only did certain women when like the title itself says it was a randomized control trial and they wanted to see what the cellular health parameters were. And I don't think they did a lot of like cellular level testing enough to know what it actually did to the cells. Like they did, they measured everybody and, they got that way, but they didn't do anything else. Oh, sorry. At a cellular level. And
I think the only other level they was they looked at the adipose tissue, the hydration versus non-hydrated, basically the contractility, conductivity of basic the resistance training, like the most cellular I found in this article. Nothing, they didn't go in depth into like they didn't talk about getting a cell from each woman, going under a microscope.
Right, like before or after or anything like that. So I personally didn't think it was as true to the title as it was.
I think it was just more like through the eye perspective versus a cellular level. They just went based on data rather than actual scientific evidence.
Yeah, I agree.
I also found it interesting the time that they took for the experiment. Like, I don't think it was long enough.
Okay, yeah.
Oh, yeah. That's true. It was, 12 weeks and 4 weeks? Is that the... Yeah, they did. It was a 12 weeks period, but then they measured at the beginning at 4 weeks, at 8 weeks, and then 12 weeks. That's pretty much... It was like... That's about it.
Yeah.
Mm-hmm.
I think for me, I mean, I doing I read here somewhere. I'm trying to find it, but it said that they just studied they just collected the data based on the exercise or resistance training. They didn't even focus anything on nutrition. I think that I was under the impression the article was going to give us information on the people's metabolic rate, which
Okay.
helps. You know, obviously, some people metabolic rate is faster than others. That's why some
Mm-hmm.
people could eat anything and for the most part be thin versus somebody has lower basal metabolic rate. You know, it takes longer for them to digest and to get rid of all those extra calories. So none of this study didn't say anything about any basal metabolic rate. So for me, I feel like that's a very biased study because we know. How do we really know? You know?
Yeah.
No, yeah.
Like there wasn't enough
Yeah, and
evidence to support
I've
that
always
at all.
been. I grew up as an athlete and everything, so once I graduated, like I basically now do just resistance training. And like whenever I read the article, it just seemed like they're just trying to turn the fat into muscle.
Yes.
Which muscle does weigh more than fat too. But what they eat too, like you said, that also has a really big part in their weight and their mass and everything.
I guess for me, that there was going to be. I feel like the resistance training itself should have been more in depth in the sense of like actually how do we go like maybe blood work, maybe a biopsy of your cells or something.
Yeah,
because
even the adipose tissue, they could have biopsied it before and after to see if there is any changes there.
Are you recording still with the phone? Sorry, I can't see it, but that's why. Oh, okay. So yeah, other things too is like they were only training for 3 times a week. I mean, obviously we know that's not enough, and they never mention anything. The older we get, the lower our metabolism slows down, our fat tissue decreases. So increases, physiologically increases. That's why you see these 20-year-olds be thinner than 60-year-olds. I mean, I'm not saying there's not 60-year-olds that are thinner, but I'm saying like because we hold on to more fat the older we get. So I feel I don't know. I just feel like it was just a very like an control study, but I don't really think it's a control study because the people were able to go home. And even in the article, it said that
it wasn't too controlled.
They were not monitored 24/7. Yeah.
And I mean, me as just a regular person reading this, like all of the math doesn't matter to me. Like I don't know what all of this means.
Mm-hmm. Yeah, that was also one of my questions. If anybody understood it.
No, not me.
No. The only thing I understand, and just from looking at it, is just a few decimals minus a few decimals, but nothing. I don't really know how they're even measuring it. How much per decimal does it even count? I don't understand it.
Yeah, no, because in the abstract it like mentions kilograms and centimeters and the percent of body fat, but everything adds up differently as well too.
And then also, my biggest thing was, I even Googled it. What's phase angle? I was like, what is
right? I don't know.
I'm like, and then when I looked into it, it's just like, for me, it says it here, is a viable indicator of cellular health with higher values reflecting better cellularity, cell member integrity, and cell function. So all that, I thought it was going to be in the article, but none of that is in the article.
Yeah.
So I was so confused. I was like, wait, I thought we were going to the cell membrane, the phospholipid bilayer, all the, is it Are we doing active transport versus diffusion versus osmosis
And I think
while we
especially because we're in that chapter 4 reading about, all this stuff, so that's what I thought too.
Yeah, but nothing really went into that. It's just really just data collection. Data collection, it does not go into depth regarding the cellular process. That's all.
I agree.
Let's see. Trying to look. Oh, and then I'm a little biased because it was 60 Brazilian older women, older than 60. It's kind of like, okay, well, their culture is different, their food is different. The States, our food is more processed. We drive vehicles everywhere.
Right, yeah.
So different.
Just like on the daily
Brazil-
life that wasn't monitored or controlled, like that could be more active than even if you have somebody that works out all the time but drives everywhere, has a sitting job, versus somebody who's like walking everywhere to get just to the grocery store to come back home. I think that would have a lot to do with it too.
I also think that the nicest study on man, in this same article, kind of compare and contrast. To I think even though we wouldn't really the similar level, but I feel like we have more answers than questions.
Yeah.
But,
or maybe even do, because like it was about older women, maybe do the same study on a younger woman to see what the difference in like what the data says, and then also take it down to the cellular level.
Yeah,
I guess
like how are you casting them?
Yeah.
How do you guys think a study like this with the title itself and the abstract saying that X, Y, and Z in the sense of cellular integrity, the cell membrane, how would you guys, if you guys were into research, what ideas would you guys come up to be able to obtain those hypotheses, to be able to get our theory from those hypotheses? How would you guys be able to, what comes to your mind?
Like, I think if we're looking at the cellular data, I think having, the true different groups, one doing exercise and one not, for sure. But then going deeper and like controlling more things, so it's a more controlled study, like their food. And then, I don't know how much, like what the biopsy would say, but I don't think, like, I think it's just to see what it looks like, what the cells look like before, and then what it looks like after, based on the title.
I think for me, since I work in cardiovascular, my specialty is ICU cardiovascular. We see a lot of CT scans, a lot of coronary artery disease. I feel like to really truly know a study like this, to be able to understand where, like, because it wants to know the mortality rates, it wants to know the comorbidities. At the end, it states that they found less. Sorry, I'm trying to bring it up real quick. Well, I was trying to get at like, right here it says. The reinforced recommendation proposed that the treatment goals for obese older adults should not necessarily focus on weight loss per se, but a lifestyle that improves fitness level status. A high fitness level may be more important for physical independence and risk mortality compared with body fatness in older adults. So for me, right off the bat is like, okay, eliminating a lot of fat because you don't want coronary artery disease. That leads to heart attacks. That leads to high blood pressure. That leads to strokes. That leads to diabetes. That leads to X, Y, and Z. So I feel like a study would be more based on, okay, let's grab those 43 women. Let's do, okay, they did an EKG. Okay, fine. That's a good one. Let's do a CT scan on everybody. Let's lower everybody's cholesterol by having them not have butter, milk, dairy,
like high fat foods.
Let's have them on the same meal plan.
Yeah. Let's do a stress test. Let's do a CTA, coronary artery disease, like a CT scan of your coronaries. Again, a stress test, and get that data from at the beginning, 4 weeks, 8 weeks, and 12 weeks. And I feel like at that point we would be able to see it more at a quote unquote cellular level, because we would be able to see, okay, this patient started with cholesterol at 100. Now her cholesterol is at 80. Everybody's eating the same thing. Everybody's exercising. So why is it that subject A went down to 80 when subject B went down to only 90? Is it genetics? Is it there's somebody? I mean, because again, this doesn't really give us much.
Yeah, it was like a scientific way of saying, like, okay, we're gonna have a weight loss challenge. Everybody is gonna go do this workout, and then in 12 weeks, tell me how much weight you've lost.
And does it even how much weight they lost? Is that in the graph?
In the graph, it tells you, like, what their BMI difference is.
Oh, okay. Oh, right there. Oh, okay. I mean, it's not a big difference. It says according to a large effect on size is greater than 0.80. Nobody really reached 0.80. The highest one was 0.68. You know, so I don't really think the average 0.55. I don't know. That doesn't really answer a lot of the questions for this kind of study, you know?
Yeah.
Yeah, no. They could have had 4 groups too. Like, one group and group 1 and 2, they're working out at the same time, but one group is on a certain meal plan and the other group is eating whatever they want. And then the next group, they're working out more and doing more, but then again, this eating will be one's on a meal plan and one's not.
And also, like, the time, like you said, I heard, like, timing. Sometimes if you work out in the morning versus the afternoon versus the evening, it changes. Yeah. That's what I'm not really sure if it's true. Let's see. Are we past time? I don't want to go in too far.
We're at 17 minutes.
Let's see. I guess my other question to you guys is, would you guys ever volunteer to do a study?
I might, yeah.
I might. A study like this?
Yeah, I mean, it's pretty broad. It doesn't seem like much work. I mean, besides, it's clear that they work 3 times a week, work out 3 times a week, Monday, Wednesdays, and Fridays. And then they have a performance, chest press, seated rows, X, Y, and Z, you know. You would do it, you said?
I think so.
I would if it was a little bit more, like, in depth with, like, eating and, like, other things like that.
Yeah, like, just to see a before and after kind of thing. I think that would motivate me to do it.
Yeah.
I would do it if they pay me.
Yeah, that too.
If they paid me, and if they would, of course, give me a meal plan, and I would work hard at my beginning, my 4 weeks, my 8 weeks, my 12 weeks, you know. And then, you know, another thing is that it's funny because, you know, how in the article it says that they didn't monitor the subject's food intake. So I'm thinking, like, what if some people were fasting and some weren't?
Yeah.
And we don't know.
That's true.
You know, yeah. I mean,
what they eat, and I also think genetics too is a really big important part when it comes to all your health.
Oh, 100%. I mean, like, my son, he's super athletic, plays every sport, doing, like, right now he's finishing up wrestling, he's about to start track and field. In the summer, he does boxing. In the fall, he does football. And then, you know, so his body, his basal metabolic rate is quick.
Yeah, he's constantly moving, and he's really active.
Very active. You know, he's 16 years old. He could eat anything he wants and never gain 1 pound. You know,
that's how I am. That's how I've been all my life. But at the same time, that's how my parents were growing up. My mom and my dad have always been really small when they were little, and not until they started aging, they started gaining more weight.
Right, because of age.
And it's how I am right now. Well, my whole life I've always been really skinny, and like people have told me like too, like, oh, like you need to eat more, and it's just like my metabolism
You're like,
is
I
just
do.
really fast. Yeah, and I could eat a lot, but it won't go nowhere. And one thing that I've noticed about myself is the only way I could gain weight is by lifting.
Yeah, like my whole life, I've been the same size. Like, I've always been a bigger person. And I've had, like, studies done because I was going to do a gastric sleeve. So they make you do all these testings. And they, like, do BMI scans. And they test your muscles. And, like, how heavy your muscles are versus your bones and all that stuff. And it's similar to, like, the scan that they were talking about. Except it's like it's like a scale, and then they like make you do all this stuff. But anyways, it's so like my bone structure is the same as an average male, and I've always been like a power lifter, so I have a lot of muscle compared to the amount of fat in my body. And
so I guess, go ahead.
No, go ahead. It's fine.
No, I'm saying, I guess if you and Ruby were both in this study, let's pretend you both were 60 years old and you guys were Brazilian. And Ruby said she's smaller, her parents were smaller, and now that they're older, they're bigger. You said you've been the same size all your life. So how is this study not even putting it out here? Like, it would be a very skewed results, because it's you're not getting another Ruby, you're not getting another Daniela, in the sense of like, okay, Ruby, we got Ruby, she's at 20% body fat. We have another subject B, she's at 20% body fat. I bet you anything, according to these body masses, they range. So how is that even? That's, for me, skewed data. That's like an invalid research.
Yeah, that makes sense.
Yeah.
Let's see. So it's, I mean, I feel like the article, what year was it? Was it even, does it say what year it was done?
I think 2018.
Oh, okay. So it's been more than 5 years. So, I mean, usually evidence practice and research is only good for about 5 years. Anything after 5, you start questioning things. So maybe that's what we're questioning it.
Yeah.
Yeah.
Oh no, October 2020.
4 years.
Okay, well, things are changing. Okay, so it's with 5 years. Okay, good. Yeah, because it says copyright 2018, National Strength and Conditioning Association. But then it says
at the bottom.
I don't even know.
I want. This is a study for on the bottom it says National Strength and Conditioning Association. So obviously somebody associated with them is the one that did that study.
Yeah.
You know, so could be good, could be bad, because you had to really, really look and see how much of the study is really worth talking about, you know?
And they were comparing older women too with younger kids, but they didn't do no experiment on the younger kids.
Yeah, at all. It was just the 60-year-old women.
Let's see. Oh, wait. Our participant completed a health history at physical activity questionnaire and met the following including criteria: 60 years and older, body mass greater than 25. Okay, see? That's one of my questions. Okay, yes, they all their body mass index is greater than 25. But what if Ruby's is 25? What if mine is 30? And what if Daniela's is 35?
Right, yeah. Like, it's too big of a gap to say, like...
Why couldn't it be like mass greater than 25, less than 27?
Yeah.
It's a more control study right there. So instead of having 60 women, if we just close down on the body mass index, I bet you anything, they probably would have only been, instead of 40 remaining, they probably would have only had 17, 15.
Yeah.
And I think that it would be more relevant, the information that they try to portray.
I think
I agree.
even, like, it would be, like, let's say having that criteria and then having, you know, 2 60-year-olds, or, like, you know, however many 60-year-olds, and at the same time do it the same exact thing, the same meal plan, the same exercise routine on a younger group, and then compare it that way.
Yeah, I feel like there's really many ways this experiment could have got done a lot better.
Yeah.
Mm-hmm. Even
like,
here,
there's many options, but none of them